All right, guys, welcome back. So looking at page 91 and 92, I actually want to start on 91, just in case you get bored and leave this video early. When I am adding up or subtracting polynomials, it's not super tricky. It's not super difficult. You're just going to keep two things in mind when you're adding. Firstly, we want to look for like terms. And things that are like terms have the same letters to the same powers. So they are identical in every single way. Same exact letters to the same exact powers. And then you're just going to add them up. Or kind of subtract, low-key, if it's a negative number. Which leads me to subtraction as well. Like, I don't really like to subtract. So if I have a polynomial minus another polynomial, like I do here and here, I don't really subtract. Truly what I do is, first thing I do is I distribute the negative to get rid of it. Distribute the negative. And then I just add. So look for like terms. And then add or subtract based on what the number is. Just like combine them up, which kind of means addition, but kind of means subtraction if the number is negative. So one little reminder when it comes to exponents, we're not multiplying, dividing, anything like that. So your exponents here will not change. So do not change exponents. You need them to stay the same so that you can be matching things up. For instance, looking at this first example here, when I'm adding these things up, the parentheses don't really matter. There's nothing on the outsides of them. So the first number that I see is an x squared number. And so I'm looking for any other x squared numbers right here so that I know, okay, these are alike. I can just add them up now. So I'm adding up how many x squareds I have, and here I have 2, and there I have 1 for a total of 3 x squareds. The next number that I see in the line is an x, and so there's another single x right here. And so because they are the same letter, same power, I'm just going to add up how many I have, and I have 1 there for 2, so plus 2x. And then lastly, I have a number with no letter and another number with no letter, and it's a -5 and a 6, and a -5 and a 6 is a total of 1. So plus because it's positive. Another way to think about it is if we line it all up like this. But again, I'm just I'm just going to look through and pick out all of those like terms. So same letter, same power. And the first one that I see is a to the third thing. And so I'm just looking for any other to the third things. And I got -1 of them right there. So if I have 5 and -1, I have a total of 4 x to the thirds. And then I'm done with those. Now truly, and we're going to get to this in the next set of notes that I have here, truly the next one that I want to look for is the next biggest. Like the largest exponent in all of these was a to the third. We kind of want to count down from there. You want to start with the biggest and go to the smallest. That's called standard form. So I'm going to actually skip over this x to the first because the next biggest is x to the second. So here I have a 2x to the second, and I have another x to the second, and then another x to the second. And so I have 2 here, 3 there, 4 there, for a total of 9 x to the seconds. And then I'm done with those. Next, I would look for x to the first, which is just x. And I have 1 there, or actually -1 there, -5 there, or -4 there. Spoiler alert. But I don't have any others. So -1 and -4 is -5x. And then I'm done with those. And then I look for the numbers without any letters because that would be to the 0 power. So we have a 7 here, a 7 there, and a -8 there for a total of 6. And then if I wanted to be real fun and name that, it is a cubic polynomial. And this one was a quadratic trinomial. Okay, looking at the next, I do not like to subtract. I always just goof it up. So the first set of parentheses do not matter, but the second set need to get that negative distributed to it. And then I just look up for my like terms. And so I first look for the biggest power, which is x to the second, and I have one here, and I have some there. So 1 and negative 4 is negative 3x squared. Then I have, oh, I don't have any like multiple x's, so I'm just going to bring that one down. He doesn't have any buddies to combine them up with. And same thing with the 8, like nobody to combine them up with, so he just comes down. And if I wanted to name that one, it would be a quadratic trinomial. Last but not least, if we keep that first one the same because there's nothing in front of the parentheses, and then distribute the negative to the second one, so we'll have negative x squared, or yeah, negative 2x squared plus x plus 4. I'm going to go through, I'm going to look for my biggest exponent, which is 2, and combine up those for 1x squared. Then I'm done. Look for my x's, and I have negative 4 of those. And then look for my non-x's, and I have 7 of those. And again, that would be a quadratic trinomial. So just a reminder again about polynomials in general. A monomial is just one single number. So one single number, or a variable, like one single letter, or a number letter. So like a number next to a letter. But anything that is one single thing with no addition or subtraction in between it is a monomial. A binomial is the sum of two monomials, because bi is 2. And a trinomial is the sum of 3. So tri is 3. If I'm talking about the degree of a monomial, normally the degree is just the biggest one. But the degree of a monomial is a little bit different. The degree of a monomial is the sum of all the exponents. So, to be fair, all the exponents of the variables, not the numbers. So when I look at my variable here, there's only one, and so the degree is just 3, or cubic. But here I have multiple variables, and so I need to add those up, and so the degree would be 5, or quintic. But when I have a polynomial, or more than one monomial, I just take the largest. So I don't do the sum of all, I just take the greatest. So this one here has a degree of 5, this one here has a degree of 3, and this one here has a degree of 1. So the degree overall is 5, because that is the biggest, or again, quintic. Okay, so if we take a look on the inside of this one here, I want to, well, let's actually, do I want to do that? Yeah, let's do that. So let's name it based on how many terms, and then we'll name the degree. So this is 2 terms, so it is a binomial. The degree is the largest, which this has 1, this has 5, so it is 5, or quintic. Here, because there are 3 monomials, it is a trinomial. The biggest degree is 3, so cubic. This is one single term. That's just a monomial. It has no variable, so the degree is 0, which is a constant. This is also a monomial because there's just one single term there. However, since it has a variable, it does have a degree of 1, which is linear. This one is sneaky. These are like terms, so I should combine them, which means that this is really 6x minus x, so 5x plus 4. So truly, it looks like a trinomial, but is a binomial. And the largest degree is 1, so it's linear. And this one is one single number, all by itself. Nobody added up or subtracted with it. So it is a monomial. And the biggest degree here is 2, which is quadratic. Now, I was about to go to the second little part of this too, because another big thing about our polynomials that I kind of talked about when we were adding and subtracting them is to be in standard form. So when we are in standard form, that means my degrees or exponents are in order from biggest to smallest. So for this one here, I kind of need to take a look at all of them and find the biggest. So this is 4, this is a 0, this is a 3, this is a 5. And so then I need to rearrange so that I do have them in order. So it's going to be 6x to the 5th, and it's positive, so still positive. So always take the sign with it. This one here is a positive, so it's going to be plus 4x to the 4th. And they're not like terms, so I couldn't add them. Then we're going to have this one, and it's positive, so plus 5x squared y. And then lastly, this one, and it's a negative, so minus 7. Another important feature that we're really going to talk about later in this chapter, but it's good to practice now, is the leading coefficient. And a coefficient is just a fancy word for number on a letter. And the leading number on a letter is going to be the number on the first term when I'm in standard form, or really on the biggest degree. So in this case, it was 6. It's just a number. So let's do a little practice with that now. If we open this one up, if I can, we are going to rewrite these guys in standard form and then find the leading coefficient. So if I look through, I'm looking for the biggest. So 3x to the 6th, and then 9x squared, and since it's positive, it'll be plus, and then minus 4x. And so my leading coefficient is 3. When I look through here, okay, this is going to be a little work. So this is 0, 1, 2, and then 3. Oh my gosh, it's in the complete opposite order, of course. So 8xy squared and positive. And then we're going to go to the 2, which is the 6xy, and it's positive, so plus. And then the 5y, and it's positive, so plus. And then the 12, and it's positive, so plus. My leading coefficient is 8. On this one here, 2 is the biggest, so 5y squared will go first. Then we're going to go to 1, which is negative 4y, so it'll be minus 4y, and then plus 2, because it's positive. Leading coefficient is 5. Next, the largest is this negative 7x squared. Then the 6x, and it's positive, so plus, and then the 8. So my leading coefficient is negative 7. And then last but not least, the largest on this one here is x to the 5th. Then x to the 3rd, and it's positive, so plus. And then this x, which is negative, so minus x, and then plus 3. And if you don't see a number, there's always one. Alrighty, see you guys next time.